Hi everyone, welcome to another video. In this tutorial I'll be showing you how to decrypt and extract browser information like credit cards, saved passwords and stuff like that with a tool called ProjectSyphon, which I've written in Python. So to start off with, I got the idea from this article here, how to crack Chrome passwords with Python. And scrolling down, he basically just lists the steps in which he used to do this, finding the encryption key which is stored on the Windows machine, understanding the AES encryption algorithm to decrypt the saved passwords. So scrolling down here, you can see there's a file located in the Google directory. So if we go to the search bar and go percentage app data percentage, all caps, navigate to app data, local, Google, Chrome, user data, and scroll down. You should see a file called local state. Just open that up with Notepad. Press Ctrl F and type encrypted, and you should see a parameter called encrypted key and the encryption key, which is used to encrypt the credit card data and save passwords. So it's just stored in a JSON format here. So we're just going to extract that, and that's going to decrypt the passwords for us. And this is the exact same file used in Microsoft Edge, Opera and Brave as well, so it pretty much just uses the same encryption scheme for that as well. So scrolling down here, basically there's another file called login data, which is a SQLite database where all the login information is stored. So if we go back to that path, go to default, scroll down, we can see the login data file, so that's essentially where all the information is stored. And there's some Python code here. Essentially it's executing some SQL code to get the table data and table information, saving it to a variable, and also extracting the ciphertext as well. And the rest of it is basically just explaining how the AES encryption system works, extracting the IRV, and then performing some decryption. So the Google Chrome, Opera and Microsoft Edge use AES GCM 256-bit. That's the current encryption standard that they're using to encrypt the passwords. So now we're just going to download the tool for it. So we just go to GitHub /darkside security, and click on ProjectSyphon. And scrolling down through the README section here, I've just made some individual scripts that essentially extend the functionality of the original blog post that I showed you. So the script here dumps cookie data, this one dumps credit card data, this one dumps passwords and email addresses. This one here called Sneaky Fox copies the password file and database files onto another computer so you can have a look at them, which I'll be demonstrating afterwards. I've made an exfiltration script that allows you to send all the saved files over FTP or SSH securely, and a personal information dump as well, which basically just dumps all the saved personal information in the browser, like name, company name, their street address, stuff like that if they've filled it in. Supported browsers, Google Chrome version 80 plus. If you're using anything lower than that, essentially the decryption will fail and you won't be able to extract anything. Works on Opera, Firefox all versions, and Microsoft Edge. Currently works on all Windows systems. This doesn't work for Linux or Mac yet, except for Firefox. That will run on pretty much anything. And I've just listed the features so far. Decrypts all data. No decryption required for Firefox. Dumps credit cards, save email addresses, passwords, cookie data, and bypasses the antivirus as well. And I've added some features that will be added in the future versions as well. So let's just download this tool, download zip. That should be downloaded for us. So just go to downloads, extract, and these are the files here, so I'm just going to copy that onto the desktop just to make it easier. And the first thing we're going to do is install the dependencies for this project. I'm just running a virtual machine with Python already installed, so you can install the Windows binary from python.org, and remember to check the box for install path as well, just so you can execute it from the command line. So to do that we can do pip3 install -r and then copy the text file over, and that should install the dependencies for us. So as you can see, those are already installed on my system, so just take a few seconds when you do it. And the libraries I'm using are Paramiko, which is used for doing SSH connections, a library called PyCryptoDomeX, used for encryption, a library called PyWin32, which is used to execute a Windows function called PyUnencrypt data, and the next one is PyInstaller, used for compiling Python projects to .exe files, which I'll be demonstrating as well. So just open up a terminal and write Python, and just copy one of these scripts, and we're just going to execute it on the command line to dump all cookies. So as you can see, that's dumped all cookies from all the available browsers that the target has installed. Starts dumping Chrome and then goes all the way through Microsoft Edge, Opera, and Brave. I've got all the browsers installed, so it will just loop through all the saved information and dump it to a file essentially. So essentially it's written data to cookies.csv. So to find that, we'll just go to my computer, C users, IE user, and we've got a file called cookies.csv, so I'll just show you that one. So as you can see, we've just got a spreadsheet here with all the information on it. This pretty much just saves all the information in the terminal to the file. Starting with, we've got the host, which is obviously the domain or the website that the cookies are for, the cookie names, and also the cookie data itself. So essentially, if we have the target logged into our website and the session token is still valid, we can essentially compromise those sessions by changing the session token in the browser and take over their account that way. So yeah, we've got quite a lot of data there, so we could either write a script to automate this or just copy the information into the browser, either way. And I've also built an exfiltration function into this script as well, so we'll just have a look at that as well. So I'll just jump over to the attacking machine here. I'll just install SSH. Good. Now we're just going to start the SSH server. So to do this, go sudo service SSH start, and change the start to status, and as you can see, it's active and running. So you go over to the Windows machine again and just select yes. It's going to ask you for the IP address or domain of the SSH or FTP server, so just enter that in. Enter the username, enter the password, and it will ask you for a port. If you're using a standard port for SSH, it will be 22. For FTP, it will be 21. But if you've port forwarded, just put whatever port it's running on. Now you can exfiltrate over FTP or SSH. For SSH, just type in SSH. It doesn't have to be in capitals. And if you're using FTP, just type in FTPS. So you can see the cookies.csv file got sent to the SSH server, and I've also imported a cleanup script that deleted the original file so the target doesn't get suspicious. And so let's just jump over to the attacking machine and we should have those files. As you can see, cookies.csv, I'll just open it to show you the data is still intact. So you can see all that data is still here. So we've basically just copied it to the attacking machine. I'm just running this locally in a virtual machine. Normally you would just purchase a virtual private server anonymously, and then just copy the data to there, copy it to your personal machine, then destroy the machine. But yeah, you can just do something locally if you want to test it out. So going back to the Windows machine, I'll basically just show you all these other scripts as well. So the next one I'll be demonstrating is dumping the credit card data. And you can see that's been done. It's got Chrome, Edge, Opera and Brave. If one of these browsers aren't installed or there's no saved data, it'll just come up empty. So if you get that, that's probably why. Looks like it's saved that file. Let's check if it's there. Yeah, it's there. And we'll just exfiltrate that data as well. That's been exfiltrated. And we've got that file there as well. Moving on to the next one. And next we'll dump all the passwords. Exfiltrate that as well. We've got that, and the last one is personal info. And we'll just exfiltrate that as well. Go over to the attacking machine. I will just review what's in that file. Now there is a bit of a bug in the way this data is written to the CSV file. As you can see, it's on the next line here. That's basically because I've got multiple functions and I haven't figured out how to fix this yet. So basically you just have to move the email address and phone number to the next line above to match it, and do the same with company name on the top row, and do the same for the other ones that have been mismatched. I'll fix this bug when I have some more time, and I'll just review all the other files to make sure they're all intact as well. So for passwords, we've got Facebook, Instagram, Facebook, Instagram again, and the usernames and passwords for those accounts. And this is the credit card data. It'll store the nicknames, the expiry month, the expiry year, credit card name and the card number. And sometimes you'll see some weird lines like this where it's got 4.1 point plus 16, 17. I've just put in random long numbers, so that's why it's stored in that format. Normally normal credit cards won't have this, so yeah, you probably won't see this on a normal data dump, so just keep that in mind. So the only other script we've got left is the Sneaky Fox script. So getting the information from Firefox is a little bit easier. So essentially all we have to do is, I'll just show the files. Just click on Mozilla, Firefox, Profiles, Release, and just scroll down. Essentially all the logins are stored in logins.json. So just click on this file here. And this is the logins data form. As you can see, the username is encrypted and the password is encrypted as well. But we do have the website name here. So essentially, to view this in unencrypted format, we essentially just need to copy the logins.json. The password is stored in key4.db. Older versions it'll be key3.db, and some other files like places SQLite, and form history, and there's another one called cert9.db. So we're just going to copy all those files, load it onto another system, and we'll be able to view that data. So I'll just show you that one. Just run Sneaky Fox. As you can see, it's detected the operating system as Windows. It's copied logins.json, key4.db, cookies.SQLite, form history, storage, places, and cert9. And as you can see, they're all in that directory. Now we're just going to exfiltrate that data. And those files have been transferred and deleted. So going over to the attacking machine, as you can see, those files are here. So to view those encrypted passwords, we're just going to copy all of these files. Control C, go to Home, press Control H to view hidden files, and go to Mozilla, Firefox, Release, and basically just copy and paste the files into here. If this is your everyday browser, make sure you back up the old files, otherwise they won't be there. Now I'm just going to open up Firefox. Now there should be an option called passwords. Just click on that one. And as you can see, we've got two accounts here. We've got a Google account. We can see the username and password for that one, and we've got a Facebook account, so we can see that password as well. So we didn't really have to decrypt anything with this one. All we did is copy the password file over, and we were able to see those accounts. Now to get the cookie data and everything else, we basically just go to add-ons and themes, extensions, just type in cookies, install cookie manager, click on the icon, manage your cookies, and as you can see we've got a list of here of all the websites that the target has visited. For instance, python.org and all the cookies associated with that as well, and also Facebook, got the cookies on Facebook. So if they had logged into Facebook and the session was still valid, we could just copy and paste it into our browser and take over their account that way, and yeah, that kind of stuff. So obviously that's really easy to do with Firefox, and you can use this script on Windows, Linux, Mac, and that should all work. So let's just go over to the Windows machine, and if a target didn't have Python installed, you can just compile one of these scripts into .exe. So I'll just show you how to do that as well. So to compile it, just do py installer dash capital F, which basically installs it into one file, and we're just going to copy the password dump into it and hit enter. And fingers crossed this doesn't throw a byte error down the bottom. This compile process can take up to a couple of minutes, depending on your processing speed on your computer. So yeah. I think the script should be almost done. It should save all the files in that same home user directory. And you can see it's completed successfully. So the actual binary should be located in dist, and you can see we've got a password underscore dump.exe, so that's our binary file there. And might have been picked up by the antivirus, but I think that might have been picked up, so I'll just try another one, see if that's going to work. So in the meantime, while that's compiling, I'll just open up Firefox, and essentially sometimes browsers will have master passwords that basically encrypt the password information in cookies, which is an idle thing to protect yourself against these kinds of attacks. So we'll just look at how to do that. Basically just scroll down, you've got a box here called use primary password, so you can basically just enter a password here. I'm just going to do test and test. Obviously if you're setting up a master password, you'll probably want to make sure it's a long string which isn't located in a something that someone could brute force. So I'm just going to click OK to that one. That's been changed. So now if we want to click on passwords, view the password, we now need that primary password that we've set. So we'll just type in test and we can see that password here. And so if someone does have that, there's actually a tool called Fox Brute. We can actually brute force that password. So I'll demonstrate that one as well. So just type in Fox Brute GitHub. So this is the project here. There's a compile project, so we're just going to download that binary. download release.zip. Looks like that might have worked, so we'll just have a look at that one. Cookie.dump. Yeah, looks like that's been picked up by the antivirus. It was, I think it was working a couple of days ago, but I'll have to make some changes to get that past the antivirus and that kind of stuff. So it looks like that's been downloaded. Extract release. So this is our well list here, which has all the potential passwords we want to try and brute force here. Obviously you can add your own or import another list, but you have to name it the well list.txt, the exact same. So the first things we'll need that key file. Just navigate to app data. Mozilla, Firefox, profiles, and release. So we pretty much just need the key for.db. Just copy it to that directory. Open the brute force binary. So now we just need to import our key file. And press start. And the more cores you have on your computer, the faster this is going to run. I'm just running a virtual machine, so it's a little bit slow. And you can see the master password was test, so we have successfully brute forced that password. So if someone's using a weak master password, like any variation on password, then we can essentially break through that added layer of security and access that encrypted data that we need. So other than that, yeah, so defenses for this type of attack, either I recommend not storing anything in the browser, or just encrypting everything with a strong master password to try and reduce these kinds of attacks. And I'll briefly show you the code, which is in Python, basically showing how it works and that kind of stuff. So I'll just open up the password.dump file. So I basically just stored the Windows path, local state file and login data for each of the browsers in a variable. written a script for the to clean up the files afterwards. So it's essentially looping over this files list and basically deleting any files with this file name. Here's the function to decrypt the password. It's extracting the ciphertext and the initialization vector using a slice here between 3 and 15 characters. The encrypted password, which is stored at 15 and minus 16. And going down here, this essentially opens the file local state, and extracts that encryption key that I showed you before. Uses the Windows API Win32 crypt to unprotect that encryption key, and then afterwards this is basically executing some SQL commands to basically pass information from the logins table and extracting the URL, username and password from that, looping over it, storing it in a variable, and extracting the ciphertext, and then it's executing the decrypt password function up here with passing the arguments, ciphertext and the secret key, and it's able to decrypt that password from there. And I've basically just added some functions that basically execute this on Chrome local path. So it's basically just executing the variables from up here that I've stored. So you can see it's got Chrome, Edge, Opera and Brave. And I've handled the errors, so if none of these browsers are found, then it will just return nothing and go to the next one. So, and that's pretty much, it does a similar thing for each of these files as well. It just differs a little bit. So the only thing that differs with the cookie script, it's the cookies files are located in networking a file called cookies, and it's the same for each browser. So I've just had to change the file a little bit. And also the table name is cookies, and extracting information from host keys, name and encrypted values, and it performs the same decryption on those files as well, and pretty much everything else is the same. And should be important to note, you've got to kill the processes for the browsers. Essentially, if they're open, you won't be able to open the SQLite database. It'll essentially just crash and close, so I've had to do that as well. And let's just take a look at personal info. Scroll down. You can see I've created a function called getInfo, and this has actually got multiple, it's executing multiple commands to different SQLite databases to sort of extract all the information from there. And the only way I could actually write the information for all those tables is to put spaces in the data that I want to write there, and that's why you've got line mismatch as at the moment. So I'll try and figure out a solution to that problem later on. Just opening out Sneaky Fox so we can see how that one works. I've got a variable called Linux path which stores the home folder for Linux systems in there, which is just home login.mozilla Firefox. And this one is basically detecting the operating system. If it's Windows, it'll run this function here. This is the Windows directory where everything's stored. This variable here basically just checks to see if this path exists. I'm doing an if statement here to see if this directory exists. If it doesn't, it won't go any further because the program will crash. And if this directory here is found, it will list all the folders in the directory. Because there's multiple files, and the one we want, it ends in releases-default. So I've added that to the list, and if the character length of the titles of the folders is greater than 20, it'll store that as a variable. And then from there, I've looped over the file list here, putting those in an array, and I'm basically specifying the path here using a format path and adding those stored variables to the end of it, just so it knows where to find those files. And again, it's checking to see if those files exist. If they don't, it will just ignore them. And once they are found, it will essentially copy those to the Windows home directory where we ran the script from, and it will print out the file name and copy successful. And this else part of the script as well, essentially if it's not a Windows system, it'll basically start running on Linux, and basically checks the path exists, iterates over the files, which is up here. The files is the folder, so if the length is greater than 20, it'll store it as a variable, which is I, and it'll run another loop for x in file list, which is these files here, and it'll basically just build out that path, add the stored variable to the path, check see if it exists, and copy the files over. And then later, if you want to exfiltrate them, it'll run that function here. So I'll just open this exfiltration script so you can see how that one works. I've essentially used a library called ftplib, which handles all the FTP connections, and Paramiko for all the SSH connections. And it should be noted I've used FTP_TLS, so that only works on encrypted FTP connections. If you're connecting to a FTP server that doesn't have a certificate, it will essentially crash and won't work. So I recommend setting up a encrypted FTP server on a virtual private server. You can do this all automatically with providers like OneHostCloud, so I recommend looking into that. So these are just the questions that I've asked here. Enter the domain or IP address, the username, password, and port, and that's storing those in a variable. Name, host, username, password, and port. Originally I had these being put down as a command line argument, so you would just do --hosts, --username, --password, and --port. But essentially, if you do that on a Windows machine, it's actually vulnerable to getting stored in history. So if you do password, echo password, so let's just say that's the password that I entered. To recall that on the session, we can do DOS key / history in capitals, and we can retrieve basically anything that has been inputted into the command line. Obviously this only works on this current session, so if I close out of this, open up another terminal and do DOS key / history. Obviously I don't get anything, I just get what I just put in, but if the target is running some kind of managed software where it records everything on the command line, then they're going to get access to your server where you're dumping their data. This is the same thing on Linux. There's a file called bash_history.rc, and that records everything that gets put into the bash command line. So for reasons I couldn't actually do that without compromising the server's credentials. So that's why I've done that like that. And this just asks the question if they want to exfiltrate data over FTP or SSH. If they select SSH, use the Paramako library to set up the SSH connections. Use the host port username password with a timeout of 10 seconds from the passwords that they've actually put in, and I've done error handling in case the host was invalid. The right path, which is done automatically, so you don't have to worry about that. If the username passwords was bad, return authentication failure, and if the server timed out or it didn't get a connection, you'll see that. It's common, sometimes you will get an overlap with some of the errors, but they should be mostly correct. And this is the FTP section of it. It will just use the FTP lib to set up those connections, use the host port and a time of 10 seconds. It'll try to log you into the server, and the way it copies those files, I've just verified that those files exist so it doesn't throw an error, and it'll use the function ftp.store binary, load it as an object, and upload that to the server as well. It's pretty much the same function for SSH. I've just used sftp.port send file and enumerated over those files that we specified in the other scripts, like passwords.csv, logins.csv, cookies.csv. So it's essentially enumerating, taking input from those files and enumerating over those and sending those to either the SSH server or the FTP server, and handling the errors accordingly. And as you can see, can't connect to host or login failed. Those are the two errors that you'll see using FTP. So I recommend experimenting with both SSH and FTP, and you can also use this script independently, so you could import this into a command and control server project as well, and this would work fine. So I think that's pretty much it for this tutorial. I think I've covered pretty much everything on this project that I wanted to cover. So yeah, that's just how you can dump usernames and passwords easily. Again, I've still got to work on building a proper bypass on the AV. Some AVs might detect it, some may not, but I've got to figure out a more permanent solution to that, as well as some other modifications as well that I'll be making. And I've got some other tools that I'm working on, such as a mass FTP exploitation framework. So I'll be doing a video on that when that's done. But if you want to see any other features in this tool, or you like it, just leave a comment in the video, and yeah, we'll see what we can do with it. So thanks for watching, and see you in the next one.